Hey guys, so today we're going to be talking about parent functions. As we go into this week, we're going to be talking about doing transformations on functions. So I thought it'd be a really good thing that we learn about what all the parent functions are. So our objective today is what we're going to go over first. I'm going to go through a lesson, and then I'm going to have a part where you can try and see how much you remembered or what you can need to go back and look over before I give you the you do part. So first, our objective today is that student will be able to, or you will be able to identify the parent functions, whether I give you the equation or the graph, that you'll be able to know what it belongs to. So I want to clarify two different things first. We have a family of functions, and then we have what we call parent functions. So when we have a family of functions, just like at home, you have your whole family, and there are different things that you all share in common. A family of functions also has a certain set of characteristics or traits that they all share with each other. So they all look very similar. We have parent functions, and these are the simplest form for a function family. So all other graphs, whether we move them around or whatever, all come from our simplest form, just like you come from your parents. So we have our first type, and it's a linear graph or a linear function. We call that our line graph. So if you take a look here, we have this line that goes straight through the origin. My equation is y equals x, or f at x equals x. Then I have a quadratic function. Those are U-shaped graphs. So we have f at x is equal to x squared. If you look at the graph here, it looks just like a U. Then we have our absolute value function. Notice it's inside those absolute value symbols here, and it's just x, nothing else. We have a vertex here, and it sits right on the origin. That will be 0, 0. It's always a minimum for our parent function. We also have our cubic function, and so we had quadratic, it was to the power of 2, or x squared. Now we have our cubic, that's to the power of 3, or x cubed. So we call that our tall man graph. It's because you start down on the bottom and you show how tall something has grown. So it starts on the bottom left. It kind of wiggles through the origin here, and it passes through it, and it goes straight up. It's a very steep or tall graph. We have our square root function. So our one-arm man graph, like this, one arm. And we use, if you look at the table here, we use our perfect squares as easy points to graph, and we connect them all together. Is the square root of x, or y equals the square root of x. We use 0, 0 is where it starts, down at our origin. And we use our perfect square of 1. Square root of 1 is 1, and then we jump to 4. The square root of 4 is 2, so you can see 2 right here. And then we have 9. Square root of 9 is 3. Now we have our cube root function. We also call that the Egyptian, kind of like an S-shaped graph. You can see here going like this way, and it's going like this way. So our Egyptian, the cubed root right there. So f at x, or y, is equal to the cubed root of x. Notice it also passes through the origin right there, or 0, 0. I have included in all of these function types also a table of values for you to reference if you need it. All right, so this is the time when I'm going to have you see if you can guess what these are. What I'm going to have you do in just a moment is pause the video. I want you to take your time, look at the 5 different things I have here. I have graphs, I have equations. See if you can name all of them, or see if you can, how many you can get correct. So in just a second, I'm going to have you pause and then move to the next part when you're ready. Okay, so we've got our linear, we have our absolute value, quadratic, cubic, and square root. Okay, this is your assignment for today. I want you to enter in this code, join the class, and then you're going to work on this assignment right here. You're allowed 2 tries. Have a great day.